Hello guys, you're welcome to my YouTube channel. Thanks for coming back again. If you are already a subscriber to this channel, and if you are yet to subscribe, just endeavor to click on the subscribe button and also on the bell beside it. That will notify you when we drop a new video. Okay, we want to look at the WAEC 2023 Physics Practical Optics, and we're going to use all the apparatus in this video in a very educative manner. So now let's take a look at this diagram in the screen, this paper. As you can see how it seems to be. So that is how we're going to plot or do the practical. But let's follow the procedure given to us. Okay, now let's follow by reading. You are provided with a plane mirror, which is this part of the diagram here. Okay, then equilateral triangular prism, which is this. Okay, optical pins where we put pin 1, pin 2, pin 3, pin 4. Okay, then thereafter we are also provided with other necessary materials. So in a nutshell, we are told to follow this procedure. Place the equilateral triangular prism or glass prism on the diagram, which is this one on the diagram. We place it on the paper and trace the outline ABC. So the outline ABC is actually talking of ABC. Then we complete it here. So then thereafter, so the next is we trace out the outline of the prism ABC and then we remove it. We draw a line NO such that it makes an angle of 1 high, which is this is high, equals 25 degrees with the normal. So we are drawing that line NO. Okay, sorry, that is not yet labeled. So let's label the line O, then N. So this is NO. So this line, then the angle we are going to make, which is this high, is going to be 25 degrees at first. So then thereafter, on this side AB actually, then thereafter we fix two pins R1 and R2 vertically on the line NO. We place that two pin. So after drawing the line NO, we fix two pin at the vertical lines. So then thereafter, what next is replace the prism on its outline, then place a reflecting mirror on the plane of the plane mirror, then place the reflecting surface of the plane mirror contact with the what face AC. Okay, which means after replacing the prism, we have to place a mirror here, a reflective mirror, and this is one of it. This is a reflective mirror, so we place it on that surface. And then what next? Looking through face BC, that is this face BC, looking through that face BC, what next? We fix other two pins where we see the images of the first two we have there. We fix another two pin on R3 and R4 such that the pin appear to other pins at the respective, then it be in a straight line with the images of the other pin, which is R1 and R2. Then thereafter we remove the prism and the mirror and the pins. Then we draw the line to join the point R3 and R4. Then produce line R3 R4 to meet line NO produce. Now this is the line NO produced. We draw it straight. So we produce that line to meet at point T. Okay, that's at T. According to this, then measure and record the angle theta. This is the angle theta here. That is the point where the two lines meet. Okay, you see this one is in a broken line. That is the line that comes from the images, then the one that comes from the objects. So then thereafter, we repeat the procedure for 4 other values of I to be 30, 35, 40, and 45. So in each case, we measure and record the corresponding value of theta and E. This angle here is called the angle of emergence. So then thereafter, we tabulate the reading up there. Then we plot a graph of E on the vertical axis and theta on the horizontal axis, starting both axes from the origin. Okay, then determine the slope S of the graph, and the intercept C on the horizontal axis. Then the next thing is to evaluate K equals S raised to power minus 1. So we have to evaluate K equals x raised to power minus 1 and then state the precautions that we meant to observe in the experiment. Okay, now let's start by doing the experiment. Now, this is my plain paper where the experiment is going to be carried out. So then, what next? I will have to place the mirror. I will have to place it here. The prism. So after placing it, then I'll draw my outline. So look at how it seems to look like. So let's draw the outline. That is going to be like this. The outline of the prism has been drawn. So now let's measure the length of this. So the length is actually about 3 points, not up to 4 meters actually. So then let's calculate half of it. That is where we're going to place our normal in this video. Let's calculate half of it. So let's label A, B, C. As we can see, this is it. So we calculate half of it and put our normal there. So then half of this, or probably we can calculate 2/3 of it. Let's use 2/3 of this. So 2/3 of it should be around here. So let's place at this particular side. We place our normal to this plane, and this normal should be at angle 90 to it. So let's just measure that. This is 90. So we are drawing this straight down. I actually want to make this up to 2/3, so I'm placing it here instead. So we have drawn that. So then we have to measure the angle. So don't forget, here is O, that is point O. Then we measure angle I equals 25 degrees here. So let's look at that. So how do I do that? I'm going to place my protractor on it like this. So this line that shows, I don't think you can see this. So this line runs from this to this point. So I'm placing this exact line on it, while this 90 goes with the normal. Then I will measure 25. So now the next is to place this at 25. So we place this side straight on that line on the normal. So while this 90 falls on the normal, so then we place this here. Okay, can you see this falls on the normal? So then I'll measure, this is 90, then I'll measure each interval represents you can see 10, 20, 30, 40, 50, 60, 70, 80, 90. So the interval between these is always 10. So we can actually measure. So then the next is to measure 25. So between 90 to 10 here to 80 here, you have 10. Then from 80 to 70 here, you have 20. So 25 is halfway to 60. So we put that halfway to 60, that is 25. So we draw that towards the normal. So that will give us, so the point on angle 25 has been marked. So now let's draw it, which will pass through the normal. We can draw it, extend it more. So this is T. Whichever point they meet is T. So this is it now. So now we are meant to replace the triangular prism. Don't forget, this is O, this is N. Okay, take a look at that. This is O, this is N.
So we have drawn the line where this angle here represents high, which is 25 degree. So the angle here is 25 degree now. So now let's replace the prism and then check what we want to check. So okay, I am going to place my mirror here. So after that, then I will fix two pins. I'll fix two pins at this point. Okay, this point first, then I'll fix the other one at this point. Okay, let it fall on the line very well. Okay, I'll fix that and I'm done with the pin. So I've actually fixed two pins now. So then let me return my mirror back to place. Then I go ahead to check through side BC. I go ahead to check through side BC the images of the two pins that are fixed. So now let's check through side BC and locate the two images. So let's locate them through this side. Then I can see them here. Then I fix two other pins in a straight line with the position that I saw it. Okay, because of the light present, so I'm having difficulties in fixing the pin. So let's fix it straight. One is actually here and the other is here. Okay, you can make a dot on those points that you have located. If the pin refuses to stand, you can make a dot there. So I've actually made a dot on each 2 points. Then I'll join them now. So if I have to make it stand, I will have to put this here and then put this here. So that is the locations of the pin. So then the next is to draw the outline. So to draw the outline, I'll have to remove all what is here, this. So now, how do you know if your answer is actually correct? Check this. I think they are on a straight line with each other. Yeah, and you check this, and I think they are on a straight line with each other as well. So I think that shows it is okay. Then I'll have to remove this. Then I will now draw a line passing through these points. Yeah, passing through the 2 points to meet up with line of the images. Then I'm going to use a broken line then there over there. So let's look at it. So I have this, so I've done that. Look at how it seems to look like. So then I measure this angle here to be theta. I'll measure that, this angle theta. Then I can draw a normal through this point, so I'll be able to know my angle of emergence. So I'll draw a straight line that will pass through this point straight down. So Drawing that straight line, I have made my angle of emergence visible. So then this is the line, and that line will be okay, D here. So then the angle here will be measured to be your angle of emergence, and the angle here will be theta. So let's measure angle theta. So in this case now, let's record I have high equals 25 degree. That is the value of high in this diagram. So now let's measure the value of E. Now to measure the value of E, I have to place 90 on this straight line here. The value of theta rather, I have to place 90 on the straight line. Okay, let's place 90. 90 will be on the straight line at this point, so I'll place it here. So after placing it, I will have to look at if it goes straight with 90. Okay, I think the line goes with 90. Then what next is I measure the angle from there downward. So this is 90, this is 10, 20, 30, 40, 50. So this is 50, it's approximately 51. Okay, let's say 51 degrees. So from 90 to 40 is going to be 50. Then there is a little bit increase from 40, so I have what, 51. So which is angle theta in this case is 51 degree. Angle theta is 51 degree. Then let's measure our angle of emergence E. Angle E. So to measure angle E, I will have to place my, okay, I place my 90 on dot here, going straight with this. I place my 90. So then thereafter I measure from this straight line to that point 90, or I count from 90 up to this point. So I have what, if I trace it up to 90, so I have what, 10, this is 10, 20, 30, 40, there's 41, 42, 43. Let's say that is 43 of, okay, 43 degrees. So angle of emergence is 43 degree. So now let's take a look at the diagram here. So we have measured this angle here, E, to be 43 degree, while here is 25, and the value theta here is 51 degrees. So we put that here and go for the next value of angle high, which is now 30 degree. So this is the first one. Let's go for the second reading. So then we are going to make I to be 30. So now I will place the triangular prism again and draw the outline. Let me do that for you to see physically. So I'm doing that now. Okay, to draw the outline, let me just place it this way. Then I draw this way. Then thereafter I draw from this other side as well, this way. Okay, it seems to have appear good. Okay, does this look pretty good? Let's manage that. So let's draw the normal. To draw the normal, I have to make this be at 90. So let me shift it a little bit up. So I place my normal here, 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 and here. So I want to draw that line of normal down. So I take it all the way. So that's the normal. So then I have to erase the long part of it. So this is the normal here. So we label it N, where this point is O. Yeah, so then thereafter let us make measure of angle 30 degree, as we have measured 45 here. So now as I've said it, let this 90 be on the normal like this, then this straight line be on the side of the triangle. Then you measure from 90 to 80, that's 10, 20, 30. So 30 falls at 60 degree on the protractor. So let's measure that. This is 60. So then we measure that going straight and let it pass through the point where the normal meets. So that goes straight up. So I can extend it more. Endeavor to use a pencil that shows clearly. So we have measured this to be 30 degree. So then we have to return the prism back to its position and then place the mirror outside. Don't forget to label this triangle here to be A and here B and C. So then I will place back my prism here, right here. Okay, right here. Then I place the mirror as usual. Then I try to locate the image. Okay, I'm yet to fix the first two pins. So let's fix that here. And the other one here. So then I return my mirror. So then after that, what next? We have to locate the images. So to locate the image, we have to look through this side BC to locate the image. So one is actually here. So we need to locate it well. So the first one falls here. Okay, I think it goes in a straight line. I think I've made a point, I've made a mark on that. So that's the first one. Then the second one goes here. So that is the position of the two pins. So then I will remove this and this. Then as usual, I'm going to use my ruler to check if they are on a straight line. So and I think they are. So then check from behind if they are on a straight line. I think they are as well. So then let's join these points. So I'm trying to join these points. It goes straight this way. Okay. So let it go straight this way. Okay, I've done that. So this is supposed to be in a broken line to show that it comes from the image. So this goes this way. Then from here I have a broken line. So that is it. In that case, I will draw my normal to this point again. A straight line passing through this point is the normal. Then after drawing that, I will measure this as my angle of emergence, and then I'll measure these as my angle of emergence. As we can see, our angle of emergence is here. Then I'll measure the value of angle theta. So this is point T, okay, and it also corresponds to point T here as well. So let's measure the angle of emergence. Now, firstly, let's measure angle theta. So, and to do that, I've said I'm going to place my 90-degree on this point here. So now let's place that and measure the value of that angle. So I'm going to have this is 10, 20, 30, 40. So then I have angle 40. Okay, 10. Okay, let's place it this way accurately. So we have 10, 20, 30, 40. Then this is 41, 42, 43. So when my high is equals to 30-degree, my theta is 43-degree. Now let's check the angle of emergence and see what that gives us. So I'll place 90 on this normal 90. I have to place my 90-degree on this normal and then measure the value of this angle. So in order to do that now, I have from here now I have 90, then 10, 20, 30. I'm counting 90 to 80 to be 10. So this is be 10, 20, 30, 40. Okay, then I have 50, 51, 52. Then I have 53. So I have my angle of emergence to be 53 degrees. Now, this is the first one we did for 25-degree. We got our angle of incidence. No, the angle of incidence required is 25, theta is 51, and emergence is 43. So this is the second one, which is 30. So we have theta is 43, emergence is 53. So look at the drawing, look at the diagram. So the remaining part of it, we have I equals 35. This is I equals 35 here, and then theta is 44, E is 40. Then we have the fourth one where we have 40-degree. So for the 40-degree, I is 40, which is what I'm talking about. Theta is 39, and then he is 45-degree. So now we have the last one here where high is 45-degree, then theta is 30-degree, E is 47-degree. So now let's tabulate this. Let's make a table for this. Okay, this is a table containing all the values we have: the serial number, the I, which is angle of incidence, the theta, and then the angle of emergence. So the next part of the video says we should plot the graph of E on vertical axis, E on vertical axis, and theta on the horizontal axis, starting both axes from the origin. Then determine the slope S of the graph and intercept C on vertical axis. Then intercept C on the horizontal axis. Then thereafter we determine K equals S, which is the slope raised to power minus 1. So let's go ahead to do that now. So now let's plot the graph of what we have. So this is the table right here. So as we can see the values on the table. So now let's choose a suitable scale. We are plotting the value of E on vertical axis and theta on horizontal axis. So let's plot this graph now using the values I have on E, which is angle of emergence. So I think I have from the range of 40 to 53 or thereabout. So I'm going to use a scale that will cover at least 70% of my graph book. So if I try to use 10 and I was told to start my axis from the origin, so if I start from here and I use 10, 20, 30, 40, 50, the graph is going to be so small. So let me take it down from here and then use 5, 10, 15, 20, 25, 30, 35, 40. So the graph at least will go a little bit up. So we can actually start from here. Okay, when we start from here, we have this is okay. Let's use 5 centimeter, 2 centimeter to represent 5 degree on vertical axis, that is the E axis. 2 centimeter to represent 5 degree. Okay, that is the line I'm drawing now. So on this line, we are actually using 2 centimeter for 5 degree. So then we draw the X side as well, and I think the same scale would go for that, 2 centimeter to 5 degree. So let's pick that up, starting both axes from the origin. So that's it. So I use the same scale on both E axis and theta axis. So writing the scale, the X axis is the horizontal axis, so we call it theta axis. Like I've written it here, theta axis, I use 2 centimeter to 5.00 degree. Then on E axis, I'm going to use 2 centimeter to 5.00 degree. So that is how I'm going to use it. So, and that is graph of, the title of the graph is graph of E against theta. So now let's draw the graph now, or let's place the values first. So here I'm going to have 5 centimeter, 2 centimeter to 5 degrees. So I have 5.00. Then I have 10.00. Then I have 15.00, 20.00, 25.00, 30.00, 35.00, 40.00, then 45.00. So actually I have a value up to 47 on E, so let's leave that aside. So now let's go for this, where we have 5.00, 10.00, then we have okay, then we have 50 also on theta, 50.0, that is 51. So with that, accommodate that, let's manage that. So then at the end of the day, 0 to 5, 5 to 10, 10 to 15, so I can write my theta here in degree. Then here I will write my E in degree. E in degree. So then I still continue with 15.00, 20.00, we have 25.00, then we have 30.00, we have 35.00, then we have 40.00, then we have 45.00, then we have 50.00, then we have 55.00. So this value goes. Now see my horizontal axis and my vertical axis. So then let's place the point. So when E was 43, what is the value of theta? So at 43, so how do I get 43? This is quite simple. So it means that each line on these 2 centimeter, both on X and Y, both on theta and E axis, each line represents 0.5. So 2 lines represent 1 degree. So in a nutshell, what I'm going to do is I'm going to make that 51 degree, because on E axis I have 43 degree. So 43 goes from, this is 5, 10, so 43 falls after how many lines? After 6 lines. So we have 1, 2, this is first 2 line, 1, 2, that's 1, this is 2, then 3. So 43 falls here. This is where 43 falls. After counting 2, 4, 6, that is where 43 falls. So then I'll trace that 43, then going to, that is on e-axis, so it goes to 51 on theta axis. So let's trace that out. If we trace that out, we fall at this point, so let's make it here. It goes out a little bit because our graph will not capture 51. So then the next is we have 53, 53 on E goes for 43 on theta. So on E we have 53, so this is 50. So 53 we count how many lines? 1, 2, 3, 4, 5, 6. So this is where 53 falls. I said 1, 2, 3, 4, 5, 6. This is where 53 falls, and that goes for 43. So how do we count 43 here? So we count 6 lines as well. 1, 2, 3, 4, 5, 6. So this is where it falls. So I will have to trace that up to each other. I have to trace that up to meet up with each other. So I'm at 50 now, exactly at 50. So I have, okay, let me count it up. 1, 2, 3, 4, 5, 6. So it goes with 1, 2, 3, 4, 5, 6. Exactly on point. So I have to place it this way. Yeah. So then I have 40 on E. Exactly 40 on E. And that goes on 44. 44 is after 8 lines. 40 to 44. So this is 40, then 44 will be 1, 2, 3, 4, 5, 6, 7, 8. So then I'll trace that down to 40. Okay, this is 40, 35, 40, then 1, 2, 3, 4, 5, 6, 7, 8. So that falls here. That actually falls here. Okay, now the next is we have 45 to 39. 45 on E to 39. So 45 will definitely falls around here to 39. So where do we see 39? 39 is the last line going to 40. Okay, this is 35. 35 plus 5, we have what? 40. So this line is 40. So let it fall at the middle here. So and that goes for 45. That goes for 45. So I place it right here. That is 40. So I'll place it right here on 45. So this is 45. Okay. Now what next? Let us take the values of E to be 47. So to take 47, I have to take how many lines? This is 45. Then 2 lines is 46. Another line we have 47. So this is 41, 46, and then I have 47 here. So 47 goes for 30. So I have 30 to 47. Sorry for making that going invalid. So 30 to 47. So 40, 45, So after 45 we count 1, 2, 3, 4. So 30, then we have 1, 2, 3, 4. So this is 1, 2, that is 47. So we shade it right here. So now, how do we pick our best fit lines? We have to pick our best fit lines. If I pick it right from these two here, my intercept will fall on y-axis, and mind you, the points that are not on the line will all be at this side. So now I will have to pick a 2 points that will make my intercept be on x-axis, and then make the remaining points that are not on the line distributed on opposite side of the line. So now I'll pick these 2 points, this point and then this point. So if my line goes this way, I'm going to have my intercept on x-axis, and that is right. Then from there, the remaining 3 will fall out, but will be spread on both sides of the line, so that make it okay. So I'm picking these 2 lines as the line. So that is the best fit line because we are told to find the intercept on x-axis. So and that is it. So I've actually picked this as the best fit line. So take note, this point is the intercept on theta axis, on the horizontal axis. So now let's determine the slope s of the graph. So determine the slope s. I have this, then I can actually take it through this point downward. Okay, it goes further. So this is, I'm taking my slope. Now this is change in e degree, and this is change in theta in degree. So reading the initial value of e, I have 15. So the slope s will be equals to the first value on e, the second value of e, which is 45 degree, minus 15 degree, divided by, you can see that now, what of this? I have 40 here, and here I have, if I would count, this is 26, I have 27. So let's trace this line down. If we trace this line downward, okay, we fall at this point. So let's count. There's 26, 27. So this is 27.5. So we have 40 minus 27.5. So that is 30 over 12.5, so which is actually 2.4. So the value of the slope is 2.4. So and then the question asks us to find the value of the slope inverse, that is s raised to power minus 1. So what would that give us? So then the value of s raised to power minus 1 gives us 0.46641 41667 approximately. So that is how the experiment is being conducted here. Thanks for watching. Please subscribe to the channel and endeavor to share this channel to those who need it. Thank you.